Welcome back. A deployed AI model is not a finished product. It's a living system in a changing world. And living systems need three things: controlled change, stable configuration, and a plan for when things go wrong. That's this chapter. And if you come from IT service management, prepare for familiar concepts with unfamiliar twists. Here's our focus map. First, change. Why model updates are fundamentally different from software patches. How AI change requests and impact assessments should work. The role of advisory boards and the special discipline around emergency changes and hotfixes. Because 2 in the morning is when controls prove themselves. Second, configuration. Baselines, drift detection at the configuration level, post-change validation, and auditing change logs for the unauthorized and undocumented changes that always exist somewhere. Third, incidents. What actually counts as an AI incident versus a standard IT event? Detection mechanisms, severity classification, escalation thresholds, and the dramatic end of the spectrum, kill switches, containment, and coordinated response. And fourth, the aftermath. Root cause analysis that goes deeper than the model misbehaved, regulatory reporting obligations after AI incidents, and how to evaluate the organization's overall incident and problem management programs with AI in scope. Every lesson here connects backward to controls we've already built and forward to the monitoring chapter ahead. Subscribe if you haven't, and let's manage some change. Let's open with the mental shift this whole chapter rests on. Your organization has managed software changes for decades. Patches, releases, rollbacks, mature stuff. So why can't AI updates just ride the same process? Let me show you 4 differences, and by the end, you'll see why treating a model update like a patch is a category error. Difference 1. A patch changes what you tell it to change. A retrain changes what it learns. When developers patch software, the delta is knowable. Here's the diff, here's exactly what's different. When a model retrains on fresh data, the change is emergent. Millions of weights shift, and nobody can enumerate what behaviors changed. You know what you fed it, not what it concluded. That's why we established in Chapter 6 that a retrained model is a new model, deserving validation, not a maintenance shrug. Difference 2. Patches fix known issues, retrains can create unknown ones. A patch closes a specific defect. A retrain can silently improve overall accuracy while degrading one customer segment. Remember, harm hides in segments, and your headline metric never flinches. Software regression testing checks known functions still work. Model regression testing must check statistical behavior across populations, a fundamentally bigger ask that we'll master in the testing chapter. Difference 3. The system changes without any update at all. Here's the twist with no software equivalent. Code untouched, model untouched, and behavior still shifts because the world drifted underneath it. Chapter 3's lesson. So AI change management must govern not only deliberate changes, but the undeliberate ones. Retraining triggered by drift is a change responding to a change. Difference 4. Dependencies cut deeper. Swap a model version and downstream systems consuming its scores may misread the new distribution. Remember my story of the score scale change that waved fraud through for weeks? Patches rarely change the meaning of outputs. Retrains can. Now let's build the machinery, the AI change request, its impact assessment, and the advisory board that reviews it. The skeleton is classic ITIL. The muscles are new. So I'll focus on what's distinctive and what you, the auditor, should demand to see. First, what counts as a change in AI environments? Cast the net wide because teams instinctively cast it narrow. Obviously retraining and model version swaps, but also threshold adjustments. Remember, moving a fraud cutoff from 70 to 60 reshapes thousands of customer outcomes without touching the model. Prompt changes in generative systems. That system prompt from Chapter 2 is a policy engine. Editing it is a change. Feature additions or removals, data source swaps, library upgrades, and guardrail modifications. Here's your first audit test. Request the change policy and check its definition of change. If prompt edits and threshold tweaks aren't in scope, the policy governs the engine and ignores the steering wheel. Second, the impact assessment. And this is where AI diverges hard from IT tradition. A standard change assessment asks what breaks if this goes wrong. An AI change assessment must also ask who is affected if this works as intended. A retrain shifts decision boundaries. Some customers who were approved yesterday get declined tomorrow. So demand assessments that cover statistical impact, projected changes to approval rates, error rates, and segment-level outcomes, fairness impact, will bias metrics move, downstream impact, our dependency chains, and rollback readiness. Is the previous version genuinely restorable? Chapter 6's rehearsed rollback. Third, the advisory board. Call it a change advisory board with AI competence or a dedicated model change committee. Composition matters exactly as it did in Chapter 5. Technical voices plus risk plus the model owner. Remember, changes to a model are the owner's accountability in motion. And the same teeth tests apply. Has the board ever deferred or rejected a change? Do conditions get tracked? Do approval timestamps precede deployments or follow them? 2 in the morning. The generative chatbot is telling customers something horrifying. Or the fraud model is blocking every legitimate transaction in a region. Someone needs to change something now. Welcome to emergency changes, the moment when governance meets adrenaline. And today, we design controls that survive that meeting. First, let's respect the reality. Emergency changes are legitimate. When harm is actively occurring, waiting 3 days for the advisory board is not prudence, it's negligence. The Chapter 7 logic applies, remember? With AI operating at machine speed, the blast radius grows by the minute. So mature organizations don't forbid emergency changes, they pre-govern them. What does pre-governance look like? A defined emergency criterion. What qualifies? Active customer harm, security exploitation, regulatory breach in progress, not we're behind schedule. Deadline pressure is the great counterfeiter of emergencies. A named authority who can invoke the emergency path, connecting to our 2 a.m. test from Chapter 6, the model owner or their documented delegate. A minimum safe procedure, even in haste. The fastest sound action is usually rollback to the known good version or activating the kill switch we'll cover shortly, rather than improvising a fresh fix on production at night. And crucially, retrospective completion. The paperwork skipped in the moment gets completed within a defined window. Impact assessment, validation, board review, all of it, after the fact, but never. Now the audit angles and emergency changes are wonderfully revealing to audit. Pull the emergency change log for 6 months and ask 4 questions. Frequency. How many emergencies? Because a system with monthly emergencies has a design problem wearing a crisis costume. Legitimacy. Sample them. Did each meet the defined criterion, or is emergency the express lane for the impatient? Completion. Did retrospective reviews actually happen? Count them. Date them. And learning. Did any emergency trigger a root cause analysis and a preventive fix? Or does the same fire recur quarterly? Today we talk about knowing what your AI system actually is at any given moment. Sounds trivial? It's not. Between models, prompts, thresholds, features, and libraries, an AI system is a tower of settings. And today's 3 disciplines, baselines, configuration drift detection, and post-change validation, keep that tower described, stable, and verified. Configuration baselines first. A baseline is the authoritative, recorded snapshot of everything that defines the system's behavior. The model version from the registry, remember chapter 11, the thresholds, the system prompts, the feature list, the pipeline settings, the library versions. Think of it as the certified recipe. Why does it matter so much for AI? Because behavior emerges from the combination. The model version alone doesn't tell you what customers experience. The model at threshold 70 with guardrail version 3 does. Your audit question is beautifully simple. Show me the current approved baseline for this system and show me evidence that production matches it. Watch that second half. A documented baseline nobody reconciles against reality is a portrait, not a control. Now, configuration drift. And note carefully, this is different from the model drift of chapter 3. Model drift is the world changing. Configuration drift is the system changing, quietly, without governance. A threshold nudged during a busy week. A prompt tweaked by a helpful engineer. A library auto-updated by the platform. Each tweak is small. None went through change control. And 6 months later, production resembles the baseline the way a much photocopied form resembles the original. Detection means automated reconciliation. Tooling that regularly compares live configuration against the approved baseline and alerts on differences. Where that tooling exists, audit its alert log. Where it doesn't, perform the comparison yourself on one system and enjoy the conversation that follows. Finally, post-change validation, the discipline that closes every change. After any approved change, evidence must show the system behaves as intended. Targeted tests for what changed, regression checks for what shouldn't have, statistical checks across segments for retrains, our lesson from earlier this chapter, and a baseline update so the recipe reflects the new reality. The classic failure is the last step. Changes validated, but baselines never updated. So the next reconciliation drowns in noise and gets switched off. Last lesson, we built the disciplined path for changes. Today, we hunt the changes that never took it, the unauthorized and the undocumented. This is proper detective work, and I'll teach you the technique the way I actually practice it, as a reconciliation between two stories that should match and rarely do. Here's the core method. Every AI environment produces two records of change. The governance story, change tickets, approvals, advisory board minutes, the paperwork trail from our earlier lessons. And the technical story, what actually happened, deployment logs from the pipeline, model registry version histories, configuration snapshots, prompt repository commits, threshold audit tables, infrastructure logs. Your audit is simply this. Take a period, say 90 days, and reconcile the two stories in both directions. Direction 1. For every technical change, find its ticket. Direction 2. For every ticket, find its technical footprint. Discrepancies in direction 1 are your unauthorized or undocumented changes. Discrepancies in direction 2 are stranger and also interesting, approved changes that never happened, which tells you the paperwork and reality have fully divorced. Now, where do undocumented changes hide in AI systems specifically? Learn the favorite hiding spots. Threshold tables, often editable directly in a database, no deployment required, no pipeline log generated. System prompts, sometimes stored as editable configuration rather than versioned code. Remember, that prompt is a policy engine. Manual retrains run from a laptop outside the pipeline. Ask the registry whether every production version has a pipeline run behind it. And the subtlest one, automated changes. Pipelines that retrain on schedule or trigger. Remember chapter 3, ask whether those machine-initiated changes generate change records at all. Many organizations govern human changes meticulously, while their own automation changes production nightly, ungoverned by design. When you find discrepancies, and you will, resist the instinct to treat each as an isolated naughtiness. Pattern them. Are they clustered around one team, one system, one type of change? Clusters reveal where the official process is too slow or too painful, which is management information, not just a violations list. Your report should say both things. Here are the control breaches, and here is why the road around the toll booth is so well worn. Let's start the incident half of this chapter with a definitional question that sounds academic and is anything but. What counts as an AI incident? Get this wrong, and real harms flow quietly through processes designed for server crashes, invisible until their headlines. Here's the traditional lens. IT incident management watches for interruptions and degradations. The service is down, the API is slow, the batch job failed. Availability, performance, errors. Now ask yourself, against that lens, what does a biased lending model look like? The service is up, latency is excellent, no errors anywhere. Every traditional dashboard glows green while the system methodically harms a customer segment. That's the definitional gap, and it's why AI needs its own incident taxonomy. So, what belongs in it? I teach 4 families: performance incidents, accuracy collapse, severe drift, a model confidently wrong at scale. Remember, a drifting model doesn't crash, it smiles. Harm incidents, discriminatory outcomes, unsafe generative outputs, a chatbot giving dangerous advice or leaking personal data through its answers. Chapter 8's leakage made operational. Security incidents specific to AI, poisoning, prompt injection, model extraction, previewing, Chapter 15. And integrity incidents, unauthorized changes affecting behavior, exactly what last lesson taught you to detect. An ungoverned threshold change that shifted outcomes is an incident, not merely a process violation. Notice what unites these families. The trigger isn't the system failing to run, it's the system running while producing wrong, harmful, or compromised outcomes. That's the sentence to remember. An incident you can't detect is an incident you learn about from a journalist. So today, the machinery that notices AI incidents, grades them, and gets the right people moving: detection, severity, escalation. 3 gears, 1 clock. Detection first, and here's the organizing insight. AI incidents announce themselves through channels traditional monitoring doesn't watch. So mature detection is a lattice of sources: the statistical layer, drift metrics, accuracy against baselines, fairness bands, output anomaly detection, everything Chapter 6's dashboards and the upcoming Chapter 13 cover, wired to alert, not just to display. The human layer, and don't underestimate it: customer complaints mentioning unfair or bizarre decisions, staff override patterns spiking. Remember, when loan officers suddenly start overriding the model is telling you something through them. The reconciliation layer, last lesson's unauthorized change detection feeding incident management directly. And the external layer, humbling but real: researchers, social media, and press discovering what internal monitoring missed. Your audit test for detection is coverage mapping. Take the 4 incident families from last lesson and ask, for each, which mechanism would catch this and how fast. Families with no plausible detector are your findings in waiting. Severity next. Classification should turn on harm, not just system status. A useful AI severity model weighs how many decisions or people are affected. Remember blast radius from Chapter 4. The consequence type, financial, safety, rights. Is the harm ongoing or contained? Is it accelerating? And does it touch regulatory obligations with notification clocks? Watch for the classic miscalibration: severity schemes inherited from IT that rank a 2-hour outage above a month of quiet discriminatory decisions. Outages are visible, harm is important, the scheme must know the difference. Then escalation thresholds, the wiring from grade to action. And this is Chapter 6's triggers matured into incident form. Each severity level maps to named roles, response times, and authorities. And here's the AI-specific escalation question I always test. At what severity does someone with authority consider stopping the system? And who is that someone at 3 a.m.? Vague answers here mean the kill switch conversation, which is exactly where we go next lesson. The incident is real, It's severe and it's ongoing. Now comes the moment this chapter has been building toward stopping the machine. Kill switches, containment, and the coordination that makes response more than heroics. Let's design for the worst R properly. Kill switches first, and let's define with precision. A kill switch is a pre-built, tested capability to halt an AI system's decision-making immediately without waiting for engineering improvisation. Notice the three load-bearing words. Pre-built, because writing the shutdown script during the incident is how 6-hour disasters happen. Remember my mispricing story from chapter 6? 6 hours of losses purely from an undefined decision right. Tested, because an unrehearsed kill switch is a hope, exactly like the unrehearsed rollback. And decision making, because the switch's real question is what happens next. Kill the fraud model, and do payments halt entirely, flow unchecked, or fall to a rules-based backup? That fallback choice, remember our real-time inference lesson, is a business decision with its own risks, and it must be made in daylight, documented, not invented at midnight. Your audit questions. Does a kill switch exist for each high-tier system? Who holds the authority? Our 2 AM name again. When was it last tested? And what's the documented fallback state? Containment is the wider family. Kill is just its loudest member. Gentler options include narrowing the system's scope, disabling one model feature, one channel, one region, raising thresholds so fewer automated decisions flow, inserting mandatory human review, dropping to the previous model version, the rollback muscle, or switching the system to log-only mode, watching without acting. Mature playbooks specify which containment fits which incident family, and gentler containment often beats the kill switch because it preserves service while stopping harm. Then coordination, because AI incidents are never purely technical. The response room needs engineering and data science, obviously, but also the model owner exercising their accountability, legal and privacy. Notification clocks may already be ticking, communications, and for harm incidents, whoever can identify and remediate affected customers, which depends entirely on the decision logs we insisted on at design time. A coordination playbook names these roles, defines who leads, and rehearses tabletop exercises for AI scenarios. Ask when the last one ran and what it changed. Here's the closing image. A kill switch is a fire extinguisher. Containment options are the fire doors. Coordination is the fire drill. The incident is contained, the adrenaline fades, and now the real learning begins. Or doesn't. Today, the two post-incident disciplines that separate organizations that improve from organizations that merely survive: root cause analysis and regulatory reporting. And for AI, both come with twists. Root cause analysis first, and here's the trap to name immediately. For AI incidents, teams love stopping at the model was wrong or the data drifted. That's not a root cause, that's a symptom wearing a technical costume. Real root cause analysis keeps asking why past the mathematics into the management system. The model drifted. Why wasn't it detected? The threshold was too loose. Why? Nobody reviewed it since launch. Why? No owner was assigned after the reorganization. See where we landed? Not in the weights, in the governance, in exactly the chapters we've built together. My rule of thumb from years of doing these: if your root cause can be fixed by retraining alone, you haven't found the root cause, you found the reset button. Structured techniques help, the 5 whys, fishbone diagrams, across categories, data, model, process, people. And importantly for AI, the analysis should examine the whole lattice. Why did detection take that long? Why did escalation stall? Why did the change that caused this skip the gate? Your audit, test, sample 3 completed incident reviews and grade their depth. Do corrective actions address process and accountability, or is every action item labeled retrain and monitor? Then check the actions were actually tracked to closure, our oldest habit. Now regulatory reporting, and the landscape has real teeth. Personal data involved in the incident, Breach notification clocks from Chapter 8 may start immediately, and they are measured in hours and days, not quarters. High-risk systems under the EU AI Act carry serious incident reporting obligations to authorities. Sector regimes stack on top. Financial regulators expect operational incident reports. Medical AI incidents may trigger device reporting duties, and India's CERT-in brings its own tight reporting windows for cyber incidents. Here's the operational insight. These clocks start at awareness, so the reporting assessment must be inside the incident playbook, a named legal or compliance role in the response room from R1, deciding what's notifiable, where, and by when, with the analysis documented even when the answer is no obligation. Your audit angles. Does the playbook map incident families to reporting obligations and deadlines? Who owns the notification decision? And for past incidents, were assessments performed and evidenced? Silence in the file is not evidence of a considered no. One closing thought that connects both halves. Regulators judge organizations less by whether incidents happen and more by the maturity of what follows. Honest analysis, real remediation, timely notification. The incident is a moment, the response is a character reference. Next lesson, we zoom out and evaluate the whole program. We close this chapter the way auditors close fieldwork, by stepping back from individual incidents and evaluating the program itself. Two programs actually: incident management, which handles events, and problem management, which hunts their underlying causes across events. Let's build your evaluation frame. Start with a distinction worth teaching your auditees because it's routinely blurred. Incident management restores normal operation fast. Problem management asks why incidents keep happening and fixes the pattern. An organization can be superb at the first and hopeless at the second. Brilliant firefighters living in a wooden city, every fire extinguished heroically, none prevented. For AI, problem management matters double. Because remember our chapter's core insight. AI incidents recur through systemic causes, ungoverned changes, decayed monitoring, ownerless models, and only pattern-level analysis catches those. Now the evaluation frame. 5 lenses I apply in sequence. Coverage. Does the program's scope genuinely include AI? The taxonomy from our earlier lesson. AI severity definitions. Playbooks per incident family. Or does AI ride awkwardly inside generic IT process? Capability. Are the mechanisms real and rehearsed? Detection lattice, escalation wiring, kill switches, coordination drills, everything this chapter built, with test dates as evidence. Consistency. Sample incidents and check the process was actually followed. Classifications defensible, timelines documented, reporting assessments present. Remember, we judge worst midnights, not calm Tuesdays. Closure. Are corrective actions tracked to completion? And here's my favorite metric of program honesty: the reopening rate. How often does the same incident type recur within a year? Recurring incidents are problem management's unpaid invoices. And learning, does anything structurally change? Do incident lessons flow back into change gates, monitoring thresholds, training, risk registers, Chapter 7's living register fed by real events? Or does every retrospective produce a document and no descendants? 2 field techniques to finish. First, the trend view. Pull 12 months of AI-related incidents and chart them by family, severity, and recurrence. The shape of that chart evaluates the program more honestly than any interview. Second, the cross-examination. Ask the incident manager which AI problem worries them most. Then, ask the model owners the same question. Matching answers mean a program with shared truth. Mismatched answers mean parallel realities. And you know by now which finding that is.